Hello everybody, hope that you are doing well. This is Dr. Eskam. So we continue with our series of English courses of zoology, and today we will talk about the second part of animal kingdom, which is the subkingdom of multicellulars, and exactly we will talk about the parazoans. But before, let's remind the division and the organization of the animal kingdom. So, as I said before, the animal kingdom is divided in two subkingdoms. The first one is the subkingdom of unicellular. In the subkingdom, we will find all the living beings in a single cell, and they are represented by one phylum, which is the phylum of Protozoa, and which is represented by 9 subphyla or sub branches. Okay, and today we will discover the subkingdom of multicellulars. Of course, I remind you that we are using the research or the results of Geraldine Ver. Okay, so what is the subkingdom of multicellulars? So, as I said before, the subkingdom of multicellulars regroup all the eukaryote living in a state of multicellular, multi-cells. So that's why to classify the multicellulars, we use an important criterion, which is the organization of the tissues. So, according to the tissue organization, which is the criterion of the classification, we can divide the multicellulars in 3 groups. Okay, in the first group we will put all the multicellulars that don't have any tissue. Okay, so they are called parazoan, and they are characterized by the absence of the tissue. Okay, and the second group is called mesozoa, and it represents a group that are multicellulars, but they have only one tissue. Okay, and in the third group, we will put all the multicellulars that have true tissues. OK? Donc, les pluricellulaires ont été répartis en 3 groupes selon la présence ou pas de tissus. Dans le premier groupe, qui est le groupe des parazoaires, donc ceux-là, ils ne possèdent pas de tissu malgré l'état pluricellulaire. Pour les mésozoaires, ils présentent un état pluricellulaire avec la formation d'un seul tissu. Et pour le troisième groupe, donc, ils représentent un état pluricellulaire avec la présence de vrais tissus. Bien sûr, on reviendra à chaque groupe pour mieux expliquer. But for today, we will talk about the parazoans. Okay, so let's discover these creatures. So the multicellular parazoans are sea creature. They are marine beings that present the multicellular state, but without formation of any tissue. Okay, they are represented by one phylum, and this phylum is called phylum of sponges, of sea sponges, or phylum of porifera. OK? In French, c'est l'embranchement des spongiaires ou alors des porifères. Et in Arabic, it is isfanj al-bahr. Okay? So, these living beings live in sea. Okay, and let's discover these creatures. So I have already shown this picture for you. Okay, but you can make your own research and discover other photos, because there are several photos representing these creatures. Okay, so as you can see, there are different colors, different forms. Okay, but let's see that they are marine beings. Okay, and we recognized about 9,000 species. Okay, as you can see, they represent the multicellular state. Okay, so they don't have one cell, they have several cells, but they don't have tissue. Okay, let's talk now about their general characteristics. Okay, so when I present general characteristics, I have an objective. Okay, so my objective is to show you that this group is more evolved comparing to the last group. Okay, and each time there are present a new group, it should be more evolved comparing to the first group. OK? Donc, pourquoi on présente les caractéristiques générales? On les présente pour justifier l'évolution du groupe qu'on étudie par rapport au groupe précédent. Donc, à chaque fois qu'on va présenter un nouveau groupe, il sera automatiquement plus évolué que le groupe précédent. Donc, à chaque fois qu'on avancera, essayez de tracer votre échelle d'évolution, your evolution scale, okay, and you must place each group in its right place. Okay, for example, we start with protozoa, so the protozoa should be the first, and then we place the parazoan. Okay, and each time we will discover a new group, we must know where to place it in the scale, in the evolution scale. Ok, donc vous devrez être capable de placer vos groupes à fur et à mesure, puisque je présente les groupes durant tous les cours du moins évolué au plus évolué. Okay, so today I will not talk about all the characteristics, but only the most important. And the first one is about the reproduction. So here, the reproduction of the sponges is asexual. Okay, so let's remind that when we told about the reproduction of protozoa, we said that it is asexual. Okay, why asexual? Because they are very simple livings and they don't produce gametes. So the same thing is for the parazoans. So the parazoans don't produce any sexual cells. So that's why they use asexual reproduction, and exactly they will use podding. Okay, so podding, as you know, is the formation of pod, and the pod will form a new individual. Donc, chaque éponge va former un bourgeon et le bourgeon est capable de donner un nouvel individu. OK? Podding يعني التبرع. OK. Now, the second characteristic is the cells. So, the sponges have several types of cells. Okay, not only one, several types. I will talk about the types when I will show you the anatomy of the sponge. But what you must keep in mind is that the most important cells in the sponges are schwannocytes. Okay, so what is a schwannocyte? So a schwannocyte is a very simple cell located in the wall of the sponges, and it is formed from several things, but the most important is the flagellum, because I will tell you why it is the most important thing in the schwannocyte. Okay, so the schwannocyte is very characteristic of sponges. Okay. Let's move to another characteristic, which is the spicule. So here, the spicule, what is the spicule? The spicule is an organelle that ensure the maintenance of the shape of the sponges. Okay, so the sponges is a very simple animal. Okay, and to maintain a shape, la forme, hein, الشكل شكل الإسفنجة. So it use this formation, which are called spicule, and there is several types of spicule. Okay, so you have like X, like Y, Y, several forms. Okay, and in each sponge we find a kind of spicule, and these spicule are produced by specific cells which are called scleroblasts. Okay. Now, another characteristic, which is pore system. So when you observe the sponges, you see many pores. Okay, so these pores are not disposed any way, but they are a real organization of the pores. That's why we will talk about the pore systems. Okay, so from the simple to the very complicated system, each sponge will organize its wall differently, and we will see why we have three pore systems. Okay, so let's remind that the sponges are animals that live in sea, and they are fixed. Okay, so they don't move. So in order to eat, they must find a system, or develop a system in order to eat. Okay, so that's why according to the area of the sponges, if the sponges are in an area which is rich of food, so they stay in the simple type. Okay, but if the food is less, so they develop another type. Okay, and if they live in area which is very poor in food, so here the sponges will develop a complicated or complex system of in order to involve no, to increase the contact of the water in order to have more food. Ok, donc le système de pore existe parce que tout simplement l'éponge c'est un animal qui est fixé, et pour assurer sa nutrition, il doit développer au niveau de la paroi un système qui varie du plus simple au plus complexe pour augmenter la surface de contact avec l'eau et capter le plus d'aliments. Okay? So if you ask yourself what is the food of the sponges, so the sponges eat zooplankton and phytoplankton. Okay. So let's discover these systems, and let's start by the simple one. So here you have a very simple type. Okay, this type is called ascon type or asconoid form. Okay, so as you can see, the sponge is like a bag. Okay, this bag is fixed on the ground. Okay, so the principle is that the water will enter by these pores will arrive to this cavity and will go out through this big opening. OK? Donc, l'eau va rentrer à travers ces petits pores, il arrive à la cavité centrale et il sort par cette grande ouverture. OK? So, these pores are called dermal ostia. Okay, these pores are called dermal ostia, and then the water will enter through dermal ostia, arrive to this cavity, which is called spongocell, and go out through this big opening called osculum. So you have entrance, spongocell, and then osculum. Okay, so this is the circuit of the water, and of course in the spongocell we find choanocytes, and the choanocytes will guide the water and will give the water its sense. I mean, it enter by the dermal ostia and they go out through the osculum. Okay, so this is the very simple type. Now let's see the before that, excuse me, here I show you the anatomy of the wall of simple sponges. So as you can see, the sponges in general is formed from several types of cells, such as pinacocytes, porocytes, scleroblast, amoebocytes, nervous cells, and you find spicule here in the wall. Okay, and the circuit of the water is from the external area to the internal area, and it will cross the dermal ostium. Okay, so here you have the anatomy of the wall of simple sponges. Now let's move to the second one. So the second one is called second type system. Donc here you can see that in the wall it is more complicated. Okay, so the anatomy is more complicated. Déjà, vous pouvez voir que ça se passe au niveau de la paroi et la paroi, elle est plus compliquée. Alors, qu'est-ce qui se passe? C'est toujours le même principe. Donc, l'eau va rentrer de l'extérieur vers l'intérieur dans une cavité et sortir par l'oscule. Okay, so the water will enter through the dermal ostia, and then it arrive to the spongocell, and it go out through the osculum. Okay, but the difference is the presence of these canals. Okay, so these canals are called radial canals. Okay, so the radial canals here, okay, will receive the water in order to get it in the spongocell, and then the water will go out through the osculum. Okay, so this is the second type system, and let's move to the most complicated or complex form, which is locant type system. And as you can see, it is very complex. Okay, but the principle is the same. I mean, the water will enter from the external area, okay, and across all these things in order to arrive to spongocell, and then it go out through the osculum. Okay, but let's start by the first pores. So the first pores are called dermal ostia, and then from this the water will move to these structures. So these structures are called flagellated chambers, les chambres vibratiles. Okay, donc the water will arrive to the flagellated chamber, crossing these canals, which are called incurrent canals. Okay, and then from the flagellated chambers to the spongocell, it across another type of canals, which are excurrent canals. Okay, and then they arrive to the spongocell, and then they it go out through this, the osculum. Ok, donc l'eau va toujours suivre le même circuit, c'est-à-dire de l'extérieur vers l'intérieur. Elle rentre à travers les pores inhalants, dermal ostia. Elle traverse des canaux qui sont des canaux afférents, incurrent canals. Elle arrive aux chambres vibratiles, flagellated chamber. Elle sort des chambres vibratiles vers la cavité centrale à travers les canaux déférents. Ok, donc vous avez excurrent canals and incurrent canals. Incurrent canals are for the entrance of the water, and excurrent canals are for the outgoing of the water. Okay, and then they arrive to the spongocell and they go out through the osculum. Okay, and as you can see, the surface of contact of the sponges increased. So in order to capture more and to catch more food. Donc, elle augmente la surface de contact pour capter plus d'aliments. Okay, so let's finish our presentation by the classification of the sponges, and you have to know that the sponges are classified according to the chemical nature of the spicule. So you remember that the spicule is used to maintain the shape of the sponges, and it is from different chemical nature. Okay, so according to this criterion, we can divide the sponges on four classes. So the first class is the class of calcareous sponges, which is characterized by here the speakers are in calcar. In the second one, class of glass sponges, here the spicule is in glass, in silice. In the class of corneosiliceous sponges, called also demospongia, the spicule is in cone with silice. And for number 4, fibrosiliceous sponges or sclerospongia, here the spicule is in fiber with silice. Ok, donc dans la première, le spicule est en calcaire. Dans la deuxième, le spicule est en silice. Dans la troisième, le spicule, il est en corne plus silice. Et dans la quatrième, il est en fibre plus silice. Okay, so here you can call it calcarea, here you can call it hexactinellida, here you can call it demospongia, and here you can call it sclerospongia. Okay, so let's finish with some photos. So here you have an example for calcarea. You have also an example from glass sponges. Look at this, is very beautiful. And here you have demospongia with different colors and different forms, low comfort type, cycon type. You have many types of demospongia. Okay, thank you for your attention. I let you decide. You can